So number 8, let's add a 6 to the AD. And then you would compare AB to AD still, but you would say AB is greater than 6 instead of AB is greater than AD. So that's all 8 was. So it's still the same as basically 7 and 6, just a little bit more specific. And then the next one relates to the proof. And here you're looking at, well, for number 3, it wants us to show the reflexive property. So we know that the reflexive property, one side has to equal the same side. What could we say there for the side? Which side is equal to itself? And you wanted to find the 2 triangles that we're comparing to be able to do that. So if you see the 2 little triangles in the big triangle, like GJF and HFJ, those 2 triangles, is there a side that they share? JF. Okay, do you see that? The 2 little triangles, they both share the base, the JF of the big triangle. So that's the reflexive property part. Okay, so you would put JF equal to JF there. Now number 4 is how are we going to prove HFJ is greater than HJF? This one has to do with the hinge theorem, okay, because we're talking about an angle being greater than another angle. Okay, so is it the hinge theorem or is it the converse of the hinge theorem? That's what we need to know. And if you forgot, you may want to look it up. But which one relates to from sides to angles or angles to sides? That's what we need to figure out. Okay, the converse of the hinge theorem here, because that one is talking about angles being greater than each other because of sides being greater than each other. So that one's converse of the hinge theorem. And you'll have a very similar proof on tomorrow's quiz. Any questions? It's pretty simple, I think. Pretty straightforward.